All right, everyone, welcome back. I'd like to take this time to introduce myself. I am Ferris Ward. I'm a PhD candidate at the Massachusetts Institute of Technology, working under Dr. David Newman, and I'm focusing on VR and AR tactics for future space exploration. And I'm going to be chairing the next session on support tools, which is quite in line, conveniently enough. So our first talk here is effective approaches and tools to support Artemis surface activities based on Apollo lessons learned and successful recent surface exploration by Clark and colleagues. So I'll turn this over to them and they can have their time to speak.
Thank you very much. This is Pamela Clark with my colleagues Fred and Luke, who helped develop or on ground data systems at JPL, who helped to develop some of the interesting tools we'll talk about. Could I have the next slide, please?
There we go.
Okay, great. Okay. So we incorporate lessons learned from the Apollo program, upon which I've written extensively in my book right now, and also the NASA Mars surface mission tools that have human interactive components. And on that basis, we propose approaches and tools to structure a science back room, make sure we're working closely with flight personnel, including astronauts, as well as the back room, and during active operations for Artemis. Could I have the next slide, please?
Okay, Ricky, every time I go to advance it after I've opened it, it just doesn't go. Any suggestions? I'm at a total loss. Oh, okay. Let's try that.
So I'm going to talk a little bit about Apollo lessons learned, really based extensively on the Apollo Surface Journal, which was an extraordinary resource, really, to understand what worked on the moon. So that these are challenges in the development of a successful strategy for surface exploration on the moon when all resources are limited. And the astronauts really, by and large, can't use the normal geological tools. The gloves on the spacesuits are very difficult to use. So they use alternatives to conventional geology tools and equipment that's specifically tailored to work with the kind of grips that they can provide with the gloves. And we're looking at also the fact that they deployed instrument packages on the lunar surface as well, which continued to operate after they left the moon. So based on the analysis of the Apollo Surface Journal, this is the kind of way things went. So they had a highly integrated and intensive period of planning, simulation, and training, all going hand in hand with each other. A lot of it took place around Flagstaff in Arizona. And they basically developed a sampling approach, which was a regional contextual technique. In other words, they were picking up samples that were representative of the area that they were in because they had limited amount of down mass and limited amount of time. And they developed a very systematic approach for description and documentation, an oral documentation technique that was used, if you look at the Surface Journal time after time, and minimize the amount of jargon that was being used in the description that they did. And also, they figured out what resolution was appropriate for what they were doing at the moment. They did carry maps to the surface, and they did force use high resolution data in planning. But at times, they wanted to use lower resolution information to provide a context as opposed to the highest resolution information available. And also, of course, the back room was a concept that came up with to allow the astronauts to communicate with folks that had trained along with them, by the way, to as part of the exploration process. Could I have the next slide, please? Humans in the loop. What does that mean? So they had the astronauts communicating via the Capcom, and the Capcom did two things. One, pass on the questions that were asked by the back room, but they didn't want the astronauts to get overwhelmed, and they had a limited amount of time. So there were times when they filtered the requests that were being made to protect the astronauts' time, make sure that they completed the task that they had to do, priority. The backroom folks, as I said, trained along with the astronauts. They were expert geologists. The only live stream they had was voice. They had poor quality video. They did have simultaneous coverage from orbit, but that was really not available directly to them. So of course, as I said, the coverage was supplemented by after departure instruments left in place as well. What they carried to the surface with them, they did actually have physical maps. It's not that easy. That information is not easy to track down, and they had cuff lists to remind them of key things that they needed to do. And so as a result of the training that they received, they did time motion studies, they did oral documentation training, they went time after time to collect a small number of samples that would be representative of the area that they were dropped into to document what was going on in the surrounding area. They had efficient use of tools, even though they had cumbersome gloves on the suits, and they managed to stay within time constraints and mass constraints. And they had enough flexibility built into the interaction with the ground so that they were able to do their tasks. Next slide, please. So what does JPL have to offer? Well, JPL has developed a lot of tools for sampling, and also there are humans in the loop. We don't normally think of that because we think of these as Mars missions, especially as robotic, but there's always an interaction with a team on the ground. So basically, JPL has already developed tools that will reduce the data stream to what's essential, allow for flexibility in terms of the kind of information that gets sent back, tools that will be able to support science analysis during mission operations. And they're basically more and more developing tools that have evolved over time to be able to cope with shorter science planning times and more immediate direct interactions. So these are well suited to what we could be using today for Artemis. Next slide, please. There's a lot of information here. I don't want to go into detail. On the right-hand side, you see relevant Apollo lessons learned, which I've talked about. But basically, state-of-the-art allows, in summary, access to the data that's appropriate for the task at hand. Sometimes that's lower, sometimes that's higher resolution. It has flexibility built in. Enhanced contextual awareness, far more than was available for Apollo. That also means they have to be kind of careful about how much information and when you get it on demand, basically, with what the astronauts would have. A geographically distributed team that could be participating in a bigger way even than during the Apollo program, and real-time updatable terrain maps. And these are updatable to the extent that features could be added and information could be given about where it would be interesting to sample. And basically aggregation of all kinds of information, far more than they had during the Apollo program. And also support for where to sample, where to place the sensors. Could I have the next slide, please? So I've mentioned a couple of specific things in the next couple of slides. And the multi-mission geographical information system, which has all kinds of information, certainly on the moon, from different kinds of instrumentation that was taken from orbit and on the surface. Could be basically also do maps of things like where samples were, where photos were on the surface. Next slide, please. In addition, the Astro Science Targeting Toolkit for Robotic Operations, which allows a display, which in this case, of course, since we're talking hands-free operation here because of the gloves, this could be heads up in the helmet, for example, on display device. So you could have 2 and 3D settings, variable settings with information that you select, put in these settings to allow contextual information in real time and to give you a sense of where you are relative to where you've been before, et cetera, et cetera. Next slide, please. So in general, just what the ARTEMIS tools allow, rapid access, relatively streamlined pipeline process, in display of information in real time in a variety of different ways that are useful, that can change over time. Plotting of information, plotting of things like where sample sites are, potential sample in interesting areas that can change and be directed to what the astronauts are interested in at the moment. Leveraging common data sets by both people on the ground and folks on the surface of the moon. And a newer capability are being incorporated in terms of 3D tile rendering to allow very high resolution to low resolution information to be utilized. All these are displayable in real time on the moon for the astronauts, and it would be essentially immediate real-time communication with folks on the moon and between folks on the moon and on the ground. Assume we'll be aggregating data from a lot of different sources, and that there will be ongoing analysis that can take place rapidly at the same time, and you can evolve the kinds of features that you're looking at. Next slide, please. So what do we have now that we didn't have before? State-of-the-art technology to greatly increase the time at which things can happen. You know, there's still bandwidth issues, which is why you really need to be somewhat careful about completely open loop communication. That can't be, you know, I mean, and there will be bandwidth challenges, of course, but these can be dealt with because a lot of this interaction analysis can go on rapidly, either on the moon or on the ground. Flexibility that's kind of built into the system, the ability to tailor the degree of interactivity and the viewpoint that you're looking at to figure out where you want to go next. Heads-up display, displays in all kinds of different media. And of course, supporting a geographically distributed and quite varied backroom. And a strategy, these have built-in strategies for dealing with limited bandwidth or potential information overload, as this would be on demand by the astronauts to call up things when they needed them. Next slide, please. Status and summary. So there's a need for new capabilities to support a richer context and greater return on investment. And it's a good match for the capabilities that we now have in hand. JPL has already developed these state-of-the-art tools that are being in use now. They're still undergoing development, and they're available for use in planning and developing operational concepts for lunar surface activities. And current directions for platform-to-ground interactive tools include other things as well, including a current effort by DSN to expedite the platform-to-scientist interactivity that'll allow greater delivery of data at even greater bandwidth capability. Thank you very much.